Welcome to part 1 of lesson 17, which is multiplying by one digit using a rectangular array, pages 43 and 44. So multiplying by one digit using a rectangular array. Content objective 4, 4th grade, NBT, numbers base 10, B5. I can multiply a whole number up to 4 digits by a one-digit whole number. 4, 4th grade, OA, A3. I can determine how reasonable my answers are by using estimation. LO, language objective. I can use vocabulary related to multiplication to explain how to multiply multi-digit numbers. SO, social objective. I can work with others to create a model to prove the solution to the multiplication problem. Alright, so we have some vocabulary. Multiplication. The process of solving for equal groups using repeated addition, arrays, or factors. Repeated addition. Equal groups are added to find the sum. So we're adding together those equal groups. Associative property of multiplication. The way the numbers are grouped in multiplication does not change the resulting product. So here, if I do 10 times 5 times 2, if I do 10 times 5 and get 50, and then 50 times 2, I get 100. Or I could do the 5 times 2 first and get 10, and then 10 times 10 is 100. It doesn't matter the order I multiply in. I could do 10 times 2, which is 20, and then 20 times 5 is 100. You can multiply in any order. You can associate the numbers in any order, and you'll get the same result. Zero property of multiplication, also called the zero product property. The product of any number and 0 is always 0. Because if you have 50 groups of nothing, you still have a total of nothing. Or if you have no groups of 50, you have still 0. Anything times 0 will be 0, because that's how many groups of nothing you have, or how many 0 groups you have, which is going to be 0. Compatible numbers. Numbers that are close in value to the actual number and are easy to add, subtract, multiply, or divide mentally. Useful for estimation. So here we're looking at rounding. 70 is close to 72, 80 is close to 78. If we multiply those together, these are much easier to multiply. 7 times 8 is 56, so we get, and then the 2 zeros, 5,600, which is a lot easier to get to, and it'll be pretty close in value. That's our estimation using compatible numbers. So we have two ways we can estimate with one-digit multipliers. One way is rounding. We round the larger factor to the largest place. So in addition and subtraction, we rounded both. In one-digit multiplication, we just round the larger factor. Use mental math to multiply the rounded number and the one-digit multiplier. So we just round the larger one and multiply. Another way to look at it is looking at compatible numbers. Change the larger factor to the nearest compatible number. Usually that is our nearest round number, but there are some that work just as well. Compatible numbers are easily multiplied like multiples of 2, 5, 10, and 25. So if the nearest round number isn't working and you want something closer, 25s are what we usually look to as our compatible number. Then we use mental math to multiply the compatible number with the one-digit multiplier. Alright, so here we have an array. How many do we have in each row? Well, this is a rod of 10, 11, 12. So one row has 12 in it. And how many groups do we have? 1, 2, 3, 4, 5, 6, 7. Okay, well, which is the larger number, 7 or 12? 12. So we're going to round 12. Is 12 closer to 10 or to 20? 12 is closer to 10. It's only 2 away from 10. It's 8 away from 20. So 7 groups of 10 is going to give us our estimation. 7 times 10 is about 70. What is our estimated product? The estimated product is 70. What multiplication problem does a rectangular array represent? Well, what we actually have is, this is the same picture as up here, what we actually have is 7 groups of 12. So 7 groups of 12, what would that multiplication problem be? It would be 7 times 12 equals something. Now, if you don't know what 7 times 12 is, we can break this apart and do 7 times 10. 7 times 10 is 70. And then 7 times 2. 7 times 2 is 14. 20 plus 14 is 80. 70 plus 14 is 84. Is that too far from 70? Not really. And when you multiply, it's going to get a little further away than with adding and subtracting. But that's within the reasonable range. So the product is 84. So let's look at this array. What do we have here? We have 10, 20, 21, 22, 23. So we have 23 in each row. And we have 1, 2, 3, 4, 5 rows. 5 rows of 23. Well, 23 is pretty close to 25. So that is what we're going to do as a compatible number. Because 25s can be easy to count by if you think of your quarters and how much money those quarters make. So for my estimation, using the compatible numbers, I'm going to do 5 groups of 25. So 5 times 25. Well, 4 quarters makes $1 or 100 cents. So 100 plus one more group of 25 would be 125. Now this went up, so this is going to be higher than the actual product, but it shouldn't be too far off. The estimated product is 125. Next, what multiplication problem does the rectangular array represent? Well, it actually shows 5 groups of 23. So 5 times 23 will tell us our number. So I'm going to break this apart. 5 times 20 gives me 100. 5 times 3 gives me 15. And 100 plus 15 is 115. Make sure you're lining up from the ones every time. Is that too far off from 125? Nope. And I knew this would be a little bit higher, so it is reasonable. The product is 115. And if we counted 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 3, 6, 9, 12, 15, 115. Just like over here, we could do similarly looking at our blocks. 10, 20, 30, 40, 50, 60, 72, 74, 76, 78, 80, 82, 84. So these arrays are just representing the groups. So now we're going to look at representing these as arrays. So we have 17 times 5. Well, I need to represent, like up here, my tens and my ones. So I'm going to have 5 groups of 10. So I don't want to draw all 10, so I'm going to use a line to represent the rod or the group of 10. So I need 1, 2, 3, 4, 5. Those are my 5 tens. And then I need to represent those 7 ones. So 1, 2, 3, 4, 5, 6, 7. That's one group of 7. 1, 2, 3, 4, 5, 6, 7. Two groups of 7. 1, 2, 3, 4, 5, 6, 7. Three groups of 7. 1, 2, 3, 4, 5, 6, 7. Four groups of 7. 1, 2, 3, 4, 5, 6, 7. Well, 5 tens, 10, 20, 30, 40, 50. This would be 50. And 5 groups of 7, 5, 10, 15, 20, 25, 30, 35. 50 plus 35 is 85. There are 85 units in 5 groups of 17. Okay, now we're going to do it with the hundreds. So first I have to represent my 5 groups of 300. Well, to represent those, I'm going to use squares. So 1, 2, there's one group of 300, 2 groups of 300, 3 groups of 300, 4 groups of 300, 5 groups of 300. How much do I have in those 5 groups of 300? 3, 6, 9, 12, 15 hundreds. Now I need to represent those 20 tens. So there's one group of 2010s, two group of 2010s, three groups of 2010s, four groups of 2010s, five groups of 2010s. So 20, 40, 60, 80, 100. And now my 4 ones. So 1, 2, 3, one group of 4. 1, 2, 3, 4, two groups of 4. 3, 4, three groups of 4. 1, 2, 3, 4, four groups of 4. 1, 2, 3, 4, five groups of 4. 5, 10, 15, 20. Okay, so we essentially have an expanded number here. So I have 1,500 plus another 100. So that's 1,600 plus 20. 1,620. So here I've made that array to represent how many groups of 300, how many groups of 20, how many groups of 4, so that I can find my final product there. All right, now let's go ahead and practice some more with our 3-column note.